Ooh, Michael Jackson. Forever alive in our hearts. Some of the greatest music ever made. Yeah. How's everybody doing? On this stormy day, at least here in Dallas, it is quite stormy, brother. Actually, matter of fact, the past 2 days, past 2 mornings, been woken up, rudely awakened around 5 a.m. by a tornado. Not really, but nearby a tornado. There's been a lot of tornadoes. God bless the families that have been affected. It's very sad, but yeah, man, it's been Mother Nature's pissed off again. But we're not here to talk about that. We're here to talk about episode 38 of the big... Wait. Nah, God damn it. I did that. Jared, matter of fact, you got this wrong, brother. You got... Oh, no, you're good. Yeah, okay. I read it wrong. My bad. Yeah, because I wanted to scroll left, right. Okay. So quick intro, guys, for the uninitiated. This is the Swift and SwiftUI Learnalong. We are 38 episodes in as of today, as you can see, because this is episode 38. I am your host. Just call me Oat. That's right, Oat. Also known as Enor Oat. Or you can just say that guy. Or you can call me Nico. All good, brother. But I am your host. And the general sense, just to give you a general sense of what to expect here, this is what I like to call fly on the wall learning. Meaning there's no direct interaction here. You're watching me read to you effectively because I am reading the Big Nerd Ranch Guide, hence the stream's namesake, right? So I read through it. We work through the examples. I try to articulate everything that I'm thinking, which may not always be a good thing, but for the most part, we've gotten through it. So we're almost through this 800-pager. It's been a big old whopper, but nonetheless, made some great progress. I'm very happy with my choice because I waffled for a long time. Boy, a long time. In terms of, what language to really dig into deeply. So I've been very impressed with Swift. I come from my background. I worked for a service company that resold an ERP package and also wrote in-house software. I did that for a decade. Wrote a lot of SQL and some Golang, right? But not, so I would say I'm an expert level in SQL, but in programming, definitely not. I wrote a few ETL pipelines in Go using Spark to some extent and just Lambdas. But that's about the extent of it. So the good thing is for you, I would say, is anybody that kind of learns similarly to me, I would think would get a benefit from this because it's not me telling you how things are. I mean, I do phrase things that way, but everything that I'm quote unquote teaching is coming from this book, minus my anecdotes here and there, but that's the general sense here. Okay. And I say that because this is all in an effort to build an actual product that I plan on, releasing to the open market. It's not going to be open source, fuck all that. But I'm not saying fuck open source. I'm just saying I don't believe just because it's the popular thing going now. It does a lot of great things, but people still want to make money, and it's totally fine. And I'm really just saying this because just random forums, Reddit, if you can even call it a forum anymore. But, I think they're very interesting places to go for feedback. And so when I was getting feedback on my app idea and stuff like that, once I sifted through all the hate, you just get hate. You try to do anything positive, go talk about it on the internet, and you will get some hate. I don't know. It's a fact, brother. You will. But aside from all that, I can tell you that the application itself will be called MRP Panda, okay? And effectively, the target demographic is anybody with physical inventory that has a SQL backend. That's basically my target. So all of the lessons that I learned, all of the pitfalls, the downfalls, the shortcomings of the programs that I had to, implement, train on, write SQL for, all that, all those, I can't say all, I should stop saying that. A lot of, I would say the majority of the software tools I interacted with in that enterprise space are extremely lacking. So I'll just leave it at that. But just know that this is all in an effort to create a profitable business. And so the implication to that is the style is going to be a bit different than watching, a quote unquote influencer. That is not what this is. And this will never be that. I'll never be a full-time influencer. But I do plan on continuing to stream because this has been great for me. I'm more or less stalling till we get a few people in here. Not really. I'm not. No, I just talk a lot. But honestly, the stream itself has been a good way for me to be consistent. But now that I'm deep into it, I'm really enjoying it. It's a lot of fun. Hope you guys stick around. And yeah, other than that, I didn't finish saying what. Okay, so after we do this, right? So we're 623 pages into an 818 deep dive into Swift. After we do this, we're going to roll straight into a SwiftUI course. So it's not going to be Big Nerd Ranch, but it'll be some kind of course literature that I will, in the same fashion, do it all on stream, just like this book has been all on stream. Of course, I'll narrate and articulate all of the examples. We'll do all that the same way with SwiftUI. At that point, we'll have Swift and SwiftUI under our belt. And so then we will take a small break from the book learning and we'll go do some stuff that I just kind of know how to do to some extent, which would be designing my back end. So I want to design the schema for my app. So you get a look at that. And then also the API. We're just going to build like a typical JSON API. And I want to do that. That way, the next portion, well, we're not going to build the API. We'll design and maybe we'll use GraphQL just for fun. I don't know. But it'll be an API of some sort, right? And then we'll roll back into the books. So we'll go back to Big Nerd Ranch, and Big Nerd Ranch iOS programming will then be the topic. So right now it's Big Nerd Ranch on Swift, and then after it'll be Big Nerd Ranch on effectively programming directly for the Apple platforms. So that'll be great. So after we finish that, we'll start building the app. And that's where the real fun will begin. So we'll start building the app. And I think at that point, maybe I'll take a poll or something like that, to all 5 of my subs, or it'll just be on a whim. But either way, I'm either thinking after we finish the iOS book, we'll either just start building, or we may go and do like a brief Odin stream, because Odin has really been, it was a bit too much for me. Not that it's overly difficult. It actually seems quite straightforward, but I just didn't have enough context yet. But I feel like after we've worked with Swift, I definitely would be able to. But this was just more of a better entry point for me. But yeah, so that's the long-term goal of this stream. So either way, it's always going to be about learning. And then, I do some other stuff, but I'll talk about that later. But anyway, that being said, now you know what's up, kind of. Now let's take a look at what we did yesterday. So yesterday, I won't be able to explain the whole well, that's not true, because maybe I will. Yeah, so yesterday we started memory management. Yesterday was a new record for me, 4 hours and 20 minutes, 4:20 baby. But just kidding. But yeah, it was very interesting. Some of it was hard for me to grasp. I think I eventually got there. But in effect, it was talking about, it was this one. It was the Vault class, yeah. But effectively talking about how the reference counting works. So I don't think I will, honestly, I don't know it well enough to recap it well. Normally I'll talk back through it, but I think for memory management, the memory management portion of it, we went so deep into things that you don't necessarily need to know to write Swift. I just wanted to understand it. It probably wouldn't be fruitful. So we'll just carry on. And then maybe later down the road when we actually start writing programs, then we can revisit, memory again, but I'm sure we'll have plenty of opportunity to talk memory. So we'll just pick it up where we left off. And so yesterday we got through the point of working with reference, one example of reference types, and how the reference counting works, and how we can, I suppose the main thing to take away from yesterday would be this, where did it, there's a, okay, no, it's not here. There is a weak keyword somewhere, weak. I think they made us, yeah, here we go. Okay, this one right there. So in this case, if we want to, well, let's take it this way. Okay, implicitly, just by default, if you have references from one class to another, so where they have a codependency on each other, which in this case, vault, like point to it, like you can see, yeah. The vault references the vault is a property inside of asset, is that right? Yeah, so this property container is of type vault, right? And then vault depends on the asset property. So they have a codependency on one another. And so we won't go too deep because I know I just said what I said, but it's kind of hard to talk about it at all without referencing it. So we'll just look at this real quick. So they showed us this really cool memory map thing graph, memory graph in Xcode, which is pretty awesome. But effectively, we're looking at the interdependencies. There was a better, there it is right there. This guy right here. And so it was just showing us the different relationships when you have this situation where you have something like one type that depends on another and vice versa, and how that can cause memory leaks. And so when written the way that we have it now, where, let's see, where the class asset in this case has a vault inside of it, so the type vault, for the container. Whenever we write that, there is what they call a strong reference. It's implicit, meaning if we look at that, oh, where'd it go? There. This reference count here. The little 3 and the 2 and the, you see that? Yep. When we don't write that weak keyword, so when we don't say weak var, we just write the property var, property name, whatever. When you create an instance, it's going to increment that reference count up by 1. So with every reference, effectively everything that, anytime something is using it or could potentially use it, the implicit strong reference that gets created, or that the compiler interprets, is implicit when we just have a regular old property, and then we have that scenario where there's two interdependencies or codependency. If we still want to maintain that same code but want to avoid the, oh wait, where did it, no, redo that. Oh shit. Well, change, wait, what was this? Oh, change. I think I deleted something else. I forgot it saves it per line. So if you control Z, it's all relative to the line, which is cool and not cool, but whatever. So wait, is this where it was? Weak var. No. This is what I get for trying to explain it. Let me find that code. was, yeah, weak var contain. Oh, that's right. Duh. Implement total value as a computed property. Oh no, that was the warning. Okay. This is where it was. Yeah. Weak. And so we'll know this is working by, where did that, there's a little button. Oh, I gotta build it, I think. Wait, what? What do we got here? Oh, that's right, yeah. I forgot the self. Okay, now try that. I can't really explain it because I don't know it well enough. So instead I'll just show you. It's probably a better approach. Okay, so this is, I'm gonna show you the, see a little button right there? Kind of small, but this will build your little graph for you, memory graph. We don't see any now because we've removed the memory leaks. So matter of fact, let me instead, what was that button to go back? Yeah. If I remove that weak declaration, ahead of container, then we can see the problem. Okay, so let's go back now. Yeah, okay. So you see these little, it's kind of hard to see, but okay, these thingies, the little hazard symbols. So those denote a memory leak or a warning that it could cause a memory leak. And this cyclical assets portion here, that's our project. So it's very nicely and concisely breaking it down for you. So project level, and then asset, of course, is one of our types. So it's showing you per, in this case, per class, how many issues there are. Simulation is a method. So pretty cool, right? I thought so. It's very impressive. Something like this would be extremely useful, I would think, in any language. So yeah, this is awesome. Everything else down here is all standard library stuff, so you don't necessarily need to be concerned with that. At least we didn't touch any of that yet. But yeah, this just shows you where the issues are, and we solve that by using that weak reference. So by using weak, if we go back to, by using that weak keyword, then we're instead doing, God damn it, it went away. Why did it go away? Instead of having a strong reference, the implicit one, we now do we create what's called a weak reference, which a weak reference will not add to the reference count. And by not doing that, whenever, in this case, like which one of these values was nil, or which one was the optional? I think it was the vault. Yeah, okay. So the vault can be nil. And so whenever we set it to a weak reference, should the instance that it is depending on be removed, which would make this nil, the memory leak would just get dropped because it's a weak reference. So it's not going to still hold on to that in memory. It's just going to let it go and destroy it. And so the way that oh, I'm a dummy. I could have just showed you with Actually, yeah, let's do that because that'll help me too. If we can actually just see it in terms of the log, at least for the recap, and then we'll be in the right spot to get started. So let me remove the week keyword one more time. Yeah, it's all spilling back to me now. I guess I can make it a reasonable size first, brother, and then, okay, so it's not here. Wait, so I didn't add it. Oh yeah, because I was showing you the thing. Okay. All right, so now let's run this. And then if we look at the output, so we create Vault 13, we create some assets, and these are the assets here. These are the ones we defined in our main Swift. So close that up. Let me it's hard to use my mouse. I got the charger plugged into it and it's like pulling on it. It feels really strange. All right, so in main Swift, we have within this run method. All right, there we go. These are the assets. So that's where those values are coming from. And when we ran this, okay, put that back. Okay, so here we have created Vault 13, so we know it got created some assets, so it shows you, here, this is the array of assets, a rare coin, a big diamond, and then this magnum opus asset is the only one it doesn't currently have a container value. And so then we print to the log whenever we change the value through one of our methods. And then through the understanding of how the automatic reference counting, ARC, which is Swift's memory management model, since we understand how it works, this is a way of demonstrating that. So since the magnum opus is not stored anywhere, right, meaning there's no container value, that would mean that it, within the context of, wait, oh no, that's right. Yeah, because these two, this is where we're giving it the container. So we initialize the 3 assets here, right? So that's what that first or that second log entry is. And then we give coin and gem, which are our first 2 assets. Those instances of the asset, which is here, get its container property populated. Therefore, it would get a reference count initially, or it would contribute to that reference count, right? So as long as the reference count for a given variable is not 0, then when you reach the end of the scope that it's in, it'll remain, because it still thinks, something needs me, so I don't get destroyed, basically. But inside the method, if we go back to main here, since we only assigned a container to coin and gem, poem, when it gets to the end of this scope here, it has a reference count of 0, so it gets deallocated, which is what it's showing here. Which is good, that's what's expected, except this here, without that weak keyword, they're basically just showing us that this kind of code, if you're not careful, can cause issues, because this would cause memory leaks. Evidenced by, where is the... reference count 211. Yeah, this is the part. Okay. So after writing it that way, right, before we fixed it, This is the explanation. You've created two strong reference cycles, which is the term for when two instances have strong references to each other. Vault 13 has a reference to the coin via the assets property. Vault 13 has a reference to the coin, so that is here in main. So here inside that run method. So when that's initialized, it has, well, these two, by doing this actually, by running the store method, which populates the container property. So this is what it's saying, is establishing those strong references. So Vault 13 has a reference to the coin, and the coin has a reference to the vault. So on both sides of those, Vault 13, wait, the coin has a reference to Vault 13 via the container property. Yeah. So it's pretty simple. I mean, you can go back and look at that graph, but it's quite literal in its description, like, reference counting, literally how many things are referencing me within the scope. So same for Vault 13 and the gem. The memory for these instances is no longer reachable. All the variables containing references to them are gone because they ran seemingly within the scope of this method, is why they're saying that. But the memory will never be reclaimed because each instance still has a reference count greater than 0. So that's really the behavior that's being described and that we don't want. We want it to let those things go whenever no, that's right. Yeah, so we want it to we don't want the reference count at all, is actually what we want. At least specifically to the way this code was written with classes, which is another important thing to note, because this would not be an issue with if this were an enum, or if this were a struct. Those would just get copies, right? Those are value types. But since we're working with classes, this is an important thing to understand. So where does it tell me the oh yeah, here it is. All right, that is it. Strong reference cycles are one kind of memory leak. Your application allocated the memory necessary to store Vault 13 and its two assets, but it did not return that memory to the system even after your program no longer needed it. See the memory for these. Trying to see if it told us more about we care about those. Okay, here we go. In short, the vault owns an array which contains references to the assets. Yeah, that's right. So vault owns the property assets, which is an array, and it references the vault type. So that's where the cross dependencies coming in. And then they don't tell you. I thought they, well, you know what, we can just ask I had it though. So let's see why that is. So this describes the code. Let me make sure that's true. But after your run function, these references go away, leaving what you see in figure 24.2. Vault 13. So here, with two references, one to asset, and that's because of the container. Okay. Yeah, so wait, is that right? Oh, okay. Yeah, I get it. All right, so after, like, this is the scope, right, of this run method. So this was the example. So since this is all one scope, you shouldn't have, like, this is just one way to think about it, but you shouldn't have any leaks once this function runs. Because everything that needs to happen regarding anything inside the scope should be handled appropriately. But the issue is that in this case, so these are representations of what the code is. So we can just look directly at these. So you have the vault 13. Let me scoot it over so we can both see, because I'm sure I'll get lost. Okay, so the variable vault 13. These two right here. Okay. The store method, let's go look at that. Oh, and I discovered GD yesterday, which is crazy. Oh, GD. That's fucking awesome. Okay, so this is the method, and this is where we pass in the asset, which this is where the dependency comes from when we call store to the asset type. So when we have the two vault 13s, it creates 3 reference counts for that vault 13. 2 from vault 13, the variables themselves. Here, when we run the store method for coin and gem. Wait, we get 1 from var 13. What are we talking about here? Reference. Oh, okay, yeah, okay. So that's just for the, I suppose, the variable itself being initialized. And then this is the direction that the count comes from for asset whenever we run these two. So that's where these 2 arrows, this one and this one, coming from Big Diamond and Rare Coin, which are just the names of these 2 that we passed in here. So that's 2 references, and then initializing the variable itself. So there's 3 references to vault 13. Nothing references the magnum opus, this poem value here. So it gets created and then destroyed in the same run, like all within this scope. Because at the end of the scope, the reference count is 0. Right? So after we run our code without the weak, this is what's left. So this is a reflection of the log, but I think this is just easier. So, but this is what is left over. So the asset and Big Diamond still have a reference count of 1. Oh, right, yeah. So they still have a reference count of 1 after the code runs. So meaning after the method, it runs all this code and then it exits here, right, at the end of the scope. And this is still the state of things. So that's really the issue. So they were just showing us how it can happen, even though this code runs. And so if you couple this, like if we just take a very rudimentary approach, because this is the only one I got, if we look at it from this standpoint, this is as base as I can make it. Because we know that it's bad that this method runs, completes, and there's still junk hanging out there from what it created, right? And that should not happen. It should all be handled within the scope. We don't want to leave things trailing, hanging around. So how do we fix it? Well, we know that it's obviously a reference count. I mean, a reference type, because it's a class. And so we know that behaviorally, in order to get these out of memory, the reference count needs to be 0. And so how could we do that? And then finally we get to where we were at the end of yesterday, which is you can do that by using this weak keyword. So now we have a weak reference. So it still allows the code to be used in the same manner, except now when we run it, the reference that's coming from the vault, or rather from the reference that's coming from the property container that is of type vault, is no longer counted. So you can still use it, but it doesn't increment the reference count. And somewhere there is some, in one of these methods, I won't torture you because we're going to go through it anyway, but in one of these methods there's a place where if the container is nil, then it's going to be deallocated. And so effectively, by making this a weak reference, we don't add that extra 1, and so now those 2 come off of Vault 13, and then the ones on asset and rare coin are never there to begin with, and so everything can deallocate. So now it should not give us an error. I think that's about the size. Wait, what is it? Computed property. What's the problem, brother? Oh, the warning. Yeah, we did that explicitly. So this was, if you want the compiler to warn you, you can use those hash warnings. It's, according to them, a more in-your-face, as they say, method of reminding yourself to do something, but you could also do something like, you know, the to-do. Although I didn't see where, is it up here somewhere? That would be cool. Is that what this is? Oh, nope. That's memory. Is that what this is? No breakpoints. Yeah, I don't know where you actually can see your to-dos, but this changes. Oh, cool. But whatever, it doesn't really matter. That other thing, the warning, works for our purpose, so I don't know if that was the view or not, but whatever. All right, so that was a very poor recap of yesterday. Memory management. Automatic reference counting. That's what that was. But again, classes just make everything more complicated, so it's always a bit chaotic, I'll say, with class or with reference types is what I really should call them. Okay, so now we get to where we were. Yeah, I think on the whole, though, that's why I like that there's a visual tool. The fact that within the IDE there's a tool there to hedge against this stuff is great, because, yeah, otherwise you really have to lean into a deep understanding of the memory model, and that is not high on my priority list. Although I do want to understand it to some degree. Okay, so then breaking strong references. Breaking strong reference cycles with weak. Which we did, but I think I'll start here and just read through until we get to well, actually we got way further than this. 628. Wait, what? Assets append explicitly asking self. We did that self total value in the vault. Yeah, we got there. Okay, build and run. The fact that an array of assets. using a capture list. I don't think we... Well, explains why you're leaking memory. We'll just read through this. We did some of this, but I'm not exactly sure where we left off, so that's fine. All right, breaking strong reference cycles with weak. The solution to a strong reference cycle is to break the cycle. You could manually break the cycles by looping over each asset and setting its container to nil. Oh, right, which would deallocate it because it wouldn't have a reference. Okay. While you have access to those variables before the function ends. So they're saying here before the method ends, you could add code to loop over and set the container value from the vault to nil in lieu of using that weak keyword, but that's not what we did. But they're just describing that. But that would be tedious and error prone. Okay, so that's the logic. That's why you wouldn't want to do that. Instead, Swift provides a keyword to get the same effect automatically. Modify asset to make the container property a weak reference instead of a strong one. Yeah, so now in asset, and that's when we set container to weak. It's weak, brother. So we do that. And then a weak reference is not included in the reference count of the instance it refers to. So it does not increment that count. And so that's effectively the same as looping over and setting the container to nil before the method reaches end of scope. In this case, making container a weak reference means that you assign Vault 13 as the container of the coin and the gem. Vault 13's The only strong reference to Vault 13 is the Vault 13 variable in main Swift. The only strong reference is the... Okay. The only Vault 13 is the... Right. Okay, so I'm just in my head, I'm thinking of where the buckets are stored. And that's the thing I have to remember that's kind of been escaping me conceptually, is that the references are with the variables themselves. So like container itself or value, name, they all store their own reference count. And then if any of these within the scope of the type, so in this case asset, has a reference count greater than 1, then the whole class, you know, all those things remain in memory. So you can really, I mean, you can see how you could accidentally bring a lot of bullshit for the ride that you maybe didn't consider. You know what I mean? Probably not, but it makes sense to me. But effectively, if one thing is memory leaked and it's inside of a class, then that whole instance is gonna hang around, because it can't just not deallocate the one piece of it, right? It's just that whole instance of the class in this case would stay in memory. Okay. A weak reference is not included in the reference count of the instance it refers to. In this case, making a container a weak reference means that when you assign Vault 13 as the container of the coin and the gem, Vault 13's reference count does not increase. Yeah. Well said. So whenever these run, where before it did increase the reference count with the container, which is what the store method is using, or it's the property being populated by the store method. By using that weak keyword, it does not increment the reference count. Yeah. Now when vault 13 variable is destroyed at the end of run, the reference count on vault 13 drops to 0. Yeah, so I have to look at it again because it just finally actually made sense to me. So this is probably easier, at least it is to me, to take and just point at what changes. So like this is what it would be if we didn't use the week keyword, right? And so each variable is a reference count when it gets initialized. So we have vault 13 and that's a reference count. And then we have asset, or sorry, the rare coin, which is an asset, and big diamond, which is an asset. And those contribute 1 reference count each for a total of 3. When we run it with the week keyword in front of the container property, which is, it belongs to asset, whenever we create this vault 13 and add the container property, these arrows here representing the count no longer count. So these would not be there. So you can subtract 2 from 3. So then vault 13 would be the only reference at the end of the scope of that method. Therefore, it would release that memory back because we destroy it at the end of that run. So yeah, hopefully that makes sense, because that's about as plain Jane as I can make it. But it is, I do think the good thing is the tool overall. That's the main thing. As long as you can, or as long as you're aware there is a problem and you can see it, if you have good tools to help you, then you can go research, go fix it. But that was my biggest takeaway. So I was pleased as a pickle and punch to see that thingamabob, the memory graph. Okay, so then run your program. We did that. Okay, we get that. I think I've beat the dead horse sufficiently. So now let's get to, I should probably highlight this. Yeah, these were 2 rules that we were made aware of for weak references. So in order to take advantage of that keyword, you need to meet these, you need to meet these requirements. So it has to be a var. So you can't have weak let, it has to be weak var. And their type must be an optional. So that is why vault has that trailing question mark. That is how we declare an optional type. Okay. Okay. Your log statement show that the vault begins deallocating, logging its deinitializer, which is right there. That's where that string output's coming from. So when it reaches the end of scope, if you have a deinitializer, it will apply that logic before it exits. Your log statement showed that the vault begins deallocating first. It then destroys its properties, including the assets array, which is a value type, so the whole array is destroyed. When the array deallocates, so do the references it contains, which causes the asset reference counts to fall to 0. Yeah, because it was only 1, and then we drop the last reference to vault 13, which was in the scope. So it would be 0, so it gets destroyed. Allowing that to be. As each asset begins deallocating, its own deinitializer executes, showing that since the vault has already begun to deallocate, the weak container references to it have already been set to nil. Yeah. There are 2 requirements for weak references. Weak references must always be declared as var, not let. Weak references must always be declared as optional. Both of these requirements are the result of weak references being changed to nil if the instance they refer to is deallocated. Both of these requirements are the result of weak to nil. Yeah, and I suppose that's the important thing to remember under the hood, that it's still, it told us we could manually add to that method of run here. Before it exits, we could go and set the container property here to nil to get the same effect. Weak just does that or declaring it as a weak reference does that for us automatically. But that's, yeah, just a thing to remember, that it's still using the same behavior under the hood. It's just a convenience. Okay, the only types that can become nil are optionals. So weak references must be optional. Yeah. In most cases, strong reference cycles like the one you just resolved are easy to avoid. Vault is a class that stores assets, so it makes sense that it would keep strong references to the assets. Asset is a class that is contained by a vault. If it wants a reference to its container, that reference should be weak. Asset is a class that is contained by a vault. Oh, right. Now I do remember that. Yeah. When faced with two types that want references to each other, try to determine which one is the parent object in the relationship. That is the object that should own the other object with a strong reference. Yeah, so since I could have just started there, now that's bringing all of the ChatGPT conversations back. That actually helped make sense of things. So where is, in this case here's our, yeah, so if we go to the vault, right, class vault, and inside it we have this assets property, which is of type asset. And so vaults contains assets, or the asset type. Really, we should just talk about it at the type level. So vault contains asset, right there. That being the case, so there is some observance here about the actual data structure of your program. You would have to make some discernment there, right? But in this case, we can see, okay, a vault contains assets. So we can just think about it from the perspective of the physical world, because that's what we're modeling. So yeah, you wouldn't have a vault inside an asset, but you might have one or many or zero assets inside a vault. Therefore, vault can be spoken of as the parent, quote unquote parent here. It's the bigger thing, contains the other thing. And so they're saying that if you're moving upward, if your reference is moving upward in terms of like from child to parent, right? So if this was, this is the volute, this is the vault, and this is the asset. So if something inside of asset is referencing something in the vault, then you should make these weak. That's what they're saying, because it's not the parent in this case. It's contained by the other type. So we want to make those weak, and then on the other side we can have these, if it goes from vault into asset, those can be strong, which is implicit, so you don't necessarily have to write anything different, but that should be understood. And that's the general idea of all that hullabaloo that I just went through. So pardon me. All right, so then that being the case, we can finally move on. All right, now reference cycles with closures. Sometimes assets appreciate or depreciate. I actually think we went through this too. We did set, change handler. All right, I swear I'm just going to read through this to get a refresher, because I want to get to new stuff, but I thought this was new stuff, but we definitely wrote, yeah, it's all right here. Oh, I do remember that. Yeah, we did the empty closure. Yeah, so let's read through it. Okay, yeah, this was good. Okay. Sometimes assets appreciate or depreciate in value. To demonstrate some closure-related memory management behavior, you will teach asset instances to react to changes in their value using a provided closure. In your asset type, allow value to be mutable and react to value changes by executing a stored closure of type asset return void. All right, so then in asset, we added this type alias, right? So this can be thought of as a nested type that's represented by a closure. And so this just lets us, like right here below it, right? We have this property change handler, and it's of type value change handler, which we just defined up here. And so the type alias, we set it equal to this closure signature. So it takes the double, returns nothing, void. And so then we can take that type alias, instead of having to write the closure, we can just use it as a type. So change handler is of type value change handler, and this is it can be thought of as effectively, you know, when we have to create like an empty array, and then we set it equal to, how do they do the, or no, something like this, string. So when we write something like that, when we want to initialize an array, but it's empty when it starts out with, not exactly the same, but you can think of it as the same using this syntax, because this right here, underbar and then in and nothing else inside your curly brackets, represents an empty closure that does nothing. So the underbar is saying we want to ignore what would normally be a double, so whatever we pass in, so we just want to ignore it. The in keyword inside the curly brackets is basically separating the arguments on the left from the body of the closure on the right, and since there's nothing there, it doesn't do anything, and so it returns nothing, and so that's, you know, valid. It's just an empty closure. That's it. So we just initialize it using that empty closure to begin with, but we can pass it anything and use it later. So we did that, and then where is asset? Well, it must be further down. Change handler. Or I thought we did, but I don't see. Oh, there it is right there. Okay. So then we added this var value of type double. Then we get exposed to this operator here, did set. Okay. So now asset now defines a type alias value change handler. Where'd you go, buddy? Oh, this one here, which is a closure that takes the double and returns nothing. Asset also has a new property, change handler, which is here, which stores a value change handler closure, which we defined as such here. The default value of this property is an empty closure that discards its argument by using an underscore for the local parameter name. Ugh. Yeah, so that's what we represent there. And then any other object, such as a vault that contains an asset, any other object, such as a vault that contains an asset, okay, can give the asset a new change handler closure. Can give the asset a new change handler closure. The asset will execute this closure every time its value changes using a did set property observer. Wait, so let's read that one more time. The asset will execute this closure every time its value, oh, literally the value, okay, the property called value. Oh, I see, because it's, yeah, trailing closure syntax. There you go. But how often? So it changes, yeah. Strategy allows objects to react to changes in an asset's value by telling the asset what to do in response to changes in value. Okay, so anytime something changes this property in an instance of asset, it will take that value and it'll set the value property to whatever you passed in minus whatever was there previously, and then set it to that. All right. Oh, I see. Yeah, because this is representative of a like a bank account, effectively. So you need to go, up and down. Deposits, withdrawals. So that's a dynamic value. Okay. Yeah, it makes sense. Now then, we also saw where is that at? In Vault. This is where they showed us the warning. So here we set total value equal to 0 as a stored property, but we use this warning to have the compiler remind us constantly that we still need to add logic here to make it a computed property, just like we did with the value property under asset. To report your Vault's total value, you need a total value property to report it. This was just telling us about that warning, but that's pretty straightforward. All right, now update your store method to set a new change handler on the new asset. Okay. Asset dot change handler is equal to, and what do we do here? Oh, okay, so here's the closure. And then here is the single argument represented as change. And that's going to be, func store, pass that in, asset container self. Okay, yeah. So change in, and then we just want to print an asset has change value by, and then whatever that change value is, and then new total value, and it should also print that out. It needs to refer to self, and then grab the total value, which we haven't implemented yet, but that would seemingly run that recalculation and then give the new total value. And then we append the asset that we passed in back to the assets array, which is up here. But they wanted us to, let's see, change the change handler, change in print. Why change that? I thought it had to be a, let me go to definition here. Yeah, I mean, it needs to be a double, so I guess I'm just a little confused on what is change? Like, where's that coming from? They'll probably tell us. Now, update your store to set new channel new asset. This change will introduce an error, which you will fix in the next step. Okay, so we write it out. I wrote it out. Change in print. Yep, total value. Oh, because we hadn't done the self yet. Also, update your simulation to account for your coin appreciating in value. In what, main Swift? Oh, yeah, yeah. Okay, I won't read through that one because that's pretty straightforward. But, and we did that yesterday. Try to build your program now. First glance disappear, blah, blah, blah. Self. Yeah, this is where we went off the rails, or I went off the rails. The coin value is changing, but the coin gem and vault are failing to deallocate again. I think that's... Yeah, this had to have been where we hopped off. Okay, look again. Store first. Doubles. All right, and we have all of that. So that's what we got now. Asset magnum opus being deallocated. Okay. The coin's value is changing, but the coin, gem, and vault are failing to deallocate again. So now let's just rerun. And that is correct. So only the poem asset was deallocated. Okay, so now what? Coin's value is changing, but the coin, gem, and vault are failing to deallocate again. The fact that the closure strongly captures the vault explains why you are leaking memory. Where was it though? Oh, in the change handler. Okay. The asset does not actually try it again, brother. The asset actually does have a strong reference back to vault. The asset actually does have a strong reference back to vault. Let's put it into the memory graph. Okay. So from asset, we see 2. Asset, vault, asset, vault. So 2 references from asset. Gotcha. Okay. Okay. That makes sense. So the 2 coming from the asset type to the vault type, and that's what we see here. The asset actually does have a strong reference back to vault. The vault owns an array of assets. The vault owns an array of assets, which we see oh duh, right there. Okay, indeed it does. Owns an array of assets, and each asset has a change handler closure that has captured a strong reference back to the vault. And each asset, oh, because we want to store it, takes an asset, and then in the change handler, asset change. I asked it yesterday, understood it, and now I've forgotten, so I'm going to ask it again because what What in the hell is change, brother? Where did you get that from? In the below Swift code. What is... First, in the parameter in the closure assigned to asset change handler within the store method. The parameter in the closure assigned to asset change handler within the store method. This closure is called whenever there is a change in the asset's value. The parameter change represents the amount by which the asset's value has changed. When an asset's value changes, the change handler closure is triggered with the change parameter indicating how much the value has changed. What? Parameter in the closure assigned to asset change handler. Within the store method. Okay, so what is the... I'm giving it an asset of type asset. Asset.change handler. So if I go there, okay, but how? When an asset's value changes, the change handler closure is triggered. When asset's value changes, the change handler closure is triggered with the change parameter indicating how much the value has changed. The closure then prints this change and the no total value. For this to work, the asset class must have a property change handler defined as a closure that takes a double. Here's an example. I guess that's my confusion. I don't see there, it's not defined anywhere. The change isn't, or I'm just blind. Where is it at? Or not here. Asset. Which is different than, this is did set let change. This is did set. In this example, when the value of an asset changes, the did set observer calculates the change and invokes the change handler closure. I still don't. Still not clicking for me, brother. Okay. Below is my asset class. I am trying to understand where change. So it is implicit. That shit is so... I just don't like implicit things. I'm starting to realize it's it's really annoying. So you're saying I could name it anything in your asset class, the change parameter in the closure assigned to change handler is implicitly defined by the closure type. Value change handler. How? And then the store method in the vault class. Yeah. Oh, because I'm saying asset.change handler. So asset.change handler. And then I just give it, wait, store, so here's the actual value minus the old value. Change handler, which is the closure. Okay. Okay, a little weird, but I think it's slowly sinking through my skull. Change handler value, change handler, and it's equal to, so we're saying it'll set it to that change handler, which is the bucket that holds the closure. And its value minus old, so then it would pass in, or it would set the value, and then that same value would get passed in to the closure. Okay. Okay. So, okay, so it's the same as like, or not the same, it's very different, but it's kind of like saying value there, but instead we call it change because it's simply just a derived value based off of change handler. And then this expression. So it does this. And then passes it into yeah, okay. I think I get it. Head store. In this setup, value change handler is a type alias for a closure, takes double. The change handler property in asset is of type value change handler and is initialized with the default closure that does nothing. Okay, that's irrelevant. When you assign a closure to change handler in the store method, you provide a closure that takes one parameter, which you named change. That's the okay. That's always, it's really fucking me up with closures. It's like I just have to remember that the end keyword is like the separator. But when you actually write the closure, this could be anything. It's a anonymous function. So it just needs to, really the only thing that change is going to correspond to is the string that I use it in immediately after, meaning let me get rid of all the right here when I stick whatever that is there in there. But if I change this, then I would just have to change that, but otherwise I can call it whatever. So that should give me an error, right? Yeah, that's an error. Cannot find change in scope. Yeah, okay. I get it. All right, so when we call this, this can be anything. It just needs to represent, well, not anything. It just needs to be anything within these parentheses to represent the arguments that we're passing in. And because we're saying it's equal to that asset change handler, equal to this closure. And when it calls change handler, change handler, wait, but how is it getting the closure to, oh, right here, duh. Okay, so it passes, it sets asset.change handler to this tuple. Is that the right order though? So let me go back here. I thought I had it. I kind of have it. Here's the relevant part of your asset. Yeah. And then the store method and the vault. Type alias. Okay, when you assign a closure to change handler in the store method, you provide a closure that takes one parameter. Here, change is just a parameter name you choose for the closure. When the value property of an asset changes, the didSet observer calls change handler with the value change. Yeah, so that part I get, but so change in the closure comes from the value passed to change handler in the didSet observer. Receives the change in the asset's value when the didSet observer triggers the closure. Receives the change in the asset's value. Yeah. Func store. But when we actually call the, let's go to main. Oh, is that what's doing it? So coin.value, increment it by 137. Which coin would be, yeah, of type asset. Okay, so I see. I didn't get how the fuck, where is the value coming from? How's it kicking it off? Now, okay, that makes sense now though. Okay, so now so we say coin.value increment by 137, which would trigger, well, which would mean changing the value inside of the property value. And since we have this observer on, it's going to take 137 minus the old value. That doesn't sound right. 130. If I increment by 137. But either way, that's what triggers it. Yeah, so I get that value, and that is now setting the change handler value. Or setting its argument. So that would be a double. It returns nothing. Okay. Just to get it into. Oh shit. Okay, I think I just, yeah, I was not paying attention. So then it's doing 137 in that way because yeah, so we pass in the argument 137 minus the old value, which would just print an asset has changed value by minus the old value. So just 137, but we didn't get that out. Oh yeah, we did. Yeah, that's exactly what it says. So an asset has changed value by 137. Oh, I see. Because we're updating the value first. We're incrementing it by 137. And so to get this correct answer that gets printed into the string, 137 minus the old value makes sense because that is what it changed by. Man, you clever dogs. Okay, so new total value self dot, okay, we haven't got there yet, but that's okay. So man, all right, so let me go back, read it for a 19th time. Did set. Yeah, okay, so now that I get that part, this might actually make sense. So now let me see. Here, change is just a parameter. Yeah, when the value property of an asset changes, the did set observer calls change handler with the value changes. Yeah. So change and the closer to summarize changes. Okay, so but are we? Or I'll see if it can get me there. I'll just ask the question. Are we subtracting the old value from the new? Value and the to calculate the change and not necessary to turn it, but determine how much the value has changed. Oh, well, okay, semantics, buddy. But I get what you're saying. So this change value is then passed to change handler closure, which can be used to update the state of the vault or other necessary logic. Yeah. In this context, old value is a special property provided by Swift within the did set observer. Oh, so that's an actual... Okay, it holds the value of the property before the change. Yeah, so 137 minus... Yeah, it's very literal. Okay, the expression value minus old value computes the difference between the new value and the old, which gives you the change in value. This change can be positive or negative. But by writing, hey babe, by writing, what exactly? Good to see you. What exactly are the order of operations and values affected by the did set block in order? Property observer that gets called immediately after a property's value is set. It allows you to respond to changes in the value. Here's the order operations and the values affected by a did set. Ah, fantastic. Okay. Initial, oh, Jesus. Initial assignment. The property is assigned a new value. Yeah. Before the did set block executes, the new value is already stored in the property, right? Yeah, yeah. So it's already there. There's some value already there. Inside the did set block, old value represents the value of the property before it was changed. The new value of the property can be accessed directly by using the property name. Okay. So let's consider the asset class with the value property and its did set observer. Value property and its did set observer. So here, let's say the initial value of an asset is 100. You update the value to 120 by doing something like asset.value is now 120, or by incrementing it. And then storing the new value, the property value is directly assigned the new value 120. At this point, the value is 120. Okay, so the property is changed first. Did set. The did set block is triggered. Inside the did set block, old value is the previous value of value, which is 100, and our new value is 120. Okay, yeah, that part just didn't make sense to me. I'm like, how does it get changed first in the order operations, but somehow you retain the old value? But I guess I just call it magic. I guess if that's how it works, that's how it works. Calculation, change, handling, expression value minus old value. Yeah. Values affected in access order. Before did set, value holds the new value 120, and the old value holds the old value 100. Okay, inside did set, we can access both. So okay, that's good to know. But makes sense because that's what it was already saying. Operations, calculate the change. 20 past change. Here's a more concrete example of how this works in practice. Let asset equal an instance of asset with name gold and the value 100 for the value. Asset.change handler equals this closure, so change in print asset value by okay. And so since change handler is type alias to the closure shape, and that is in fact a double. So we're saying 20 in, and then print asset value changed by 20. Okay. Weird, but okay. Yeah. Okay, so what is causing Swift to, or what is telling Swift to hold onto the old value? In Swift, the old value in a did set block is automatically provided by the language's property observer mechanism. Okay, so literally just well, not magic, but it's just part of the language. So okay, so by using a did set block, we get that. Okay. When you define a did set observer for a property, Swift internally keeps track of the property's value before the change, allowing you to reference this. Here's how it works in detail. Property declaration with did set. When you declare a property with a did set observer, Swift implicitly captures the previous value of the property whenever it is about to be changed. Well, come on, brother. You just said. So this is a real, I guess I have to ask in detail and not just ask for the order of operations, because it told me up here that step by step. Yeah, so you gotta begin. Hence why you gotta keep digging. I mean, obviously this is wildly helpful, so it's pros outweigh the cons, but you know, it happens. It doesn't know you, so it doesn't know how anal you are. And it's not deterministic, so there's that. Okay, but let me just confirm. So then that means, yeah. So earlier, or let me just quote it so it knows what I'm talking about. Oh my gosh. Just fucking high. Okay, there we go. So to clarify, when you listed this as the first step, it was, or it should have been, second and the of the old value. Okay. Come on, brother. Give me the whole thing. Whole enchilada. Not a piece of it cut off. All right. So order of operations for, corrected. Capture the old. Okay, no, but that, yeah, that makes a lot more sense then. So yeah, well, I get it. I mean, now that I know that that's what is happening, that makes a lot more sense. And we'll save that. Oh, snap. On our board here. This is getting on my nerves. Order of operations. here. Okay. Sheesh. That didn't have a ton to do with memory, but it all plays its part, I suppose. Okay. So now I get it. So at some point here, saves the old value. I already have the new value because it's already in the bucket, so value minus old value. And then use the output of that expression as the change handler, what you call argument. Yeah. Change handler. Okay, so there's one more piece that I wanted to understand. Did set. Value in this case contains new value. Calculates the change in value. The change values. There we go. This change value is then passed to the change handler. Because it's equal to a closure. Okay. Did set observer. So all of that happens first, and then we execute the handler. Calculate change and execute the handler. Compute the change. Yep, so we get 20. Pass the change value to the change handler closure. Okay, so that's what that was the last part for me. And that is why so in main, we affect value here, coin.value. So on this instance, which changes this, which triggers this, which captures the old, does the math, we get the change handler is equal to a closure, so this passes in the change to the closure. And then in main, or no, where is it? Where's the store method? Is that in the vault? Yeah, here we go. So in the store method, yeah. So then we just, whenever this store method runs, it calls the change handler, which already has the new value. So 20 in, okay. Yeah. We got there. How long did that take? Almost 2 hours. Okay. All right. Build and run your program. The asset actually does have a strong reference back to Vault. Okay, this is where we were. All right. The fact that the closure strongly captures the Vault explains why you are leaking memory. The asset actually does have a strong reference back to Vault. The Vault owns an array of assets, and each asset has a change handler closure that has captured a strong reference back to the Vault. The cycle was shown in 24/7. I guess I could have looked here too, but it's more fun when you figure it out yourself. So reference count 1, Vault 13 is a reference to asset, and its change handler property is a reference to the closure. closure created in vault.store method is a strong reference back to vault 13. Captured strongly in closure. Okay. Think about the error message you saw. Requires explicit use of self. Swift could allow you to use self implicitly in closures, but doing so would make it very easy to accidentally create strong reference cycles. Wait, what do you mean? I missed something. I'm not getting an error. Self total value. The fact that the closure strongly captures. Oh, it's referring back. Okay. Think about the error message you saw. Requires explicit use of self. Swift could allow you to use self implicitly in closures, but doing so make it very easy to accidentally create strong reference cycles. Instead, the language usually requires you to be explicit about your use of self, forcing you to consider whether a reference cycle is a possibility. Okay. In cases where the compiler knows a reference cycle is impossible, such as when self is a value type and therefore is copied rather than referenced by the closure, you do not need to be explicit with self. To change the capture semantics of a closure to capture references weakly, so this is literally just the same example but with closures instead of stored properties. To capture the capture semantics of a closure, you can use a capture list. Modify vault.swift to use a capture list. Okay, a capture list. Change handler. Okay, so here. Closures are so odd. Weak, self. Now the type is ahead of the yeah, it's weird. New total value. Oh, okay. So this is now string. Describing. Self optional chaining dot total value. Asset has changed by change new total value. Okay, yeah. And now we see that our rare coin and big diamond are being deallocated. So same result, same as earlier, but with closures that time. Boy, okay. The capture list syntax, I'm not going to remember that. Hold on. The capture list syntax is a list of variables inside square brackets. Capture list syntax is a list of variables inside square brackets immediately before the list of the closure arguments. Okay, so weak and self are. I didn't realize those were two. I didn't know those were variables. I get self, but why would weak be a variable? So many questions. Capture list you wrote here. Tell Swift to capture self weakly instead of strongly. Oh, it's not a variable. It's just, I can use the keyword inside of here too. Okay, so weak self. Self is the only variable because it would represent the instance. Okay. Yeah. All right. So then now that the assets closure no longer strongly references the vault, the strong reference cycle is broken. Do not miss the new use of self optional in the body of the closure. Yeah. Right there. Because self is captured weakly, all the weak instances must be optional. Self, oh right, because it would set it to nil for you when it needs to deallocate. So it has to be able to, okay. Self inside the closure is optional. Okay. As an aside, you can also use a capture list to acknowledge an intentional strong capture of self, eliminating the need for explicitly referencing self throughout the closure. Oh, okay. Yeah. Do not change your code, but here's what it would look like. Okay. And this is why these books are awesome. Detail. You should only do this if you have code elsewhere in your program that will break the reference cycle another way, such as making change handler optional and setting it to nil later in the program. Your program does not have any special handling of this closure relationship to make the reference cycle temporary, so ensuring that self is only captured weakly is the safe move. Run your program again and confirm all the instances are being deallocated, and they are. Once again, the strong reference cycle is broken, and all your objects are deallocating when you expect them to. Okay. Escaping and non-escaping closures. Yikes. How long? What's left in this chapter? I might break it up because there's a lot of oh, it's not much. Yeah, let's finish it. Okay, escaping and non-escaping closures. Imagine that rather than using an empty closure as the default value, rather than using empty closure, as the default value of assets change handler property. So referring to change handler. So instead of doing this, instead of doing that, you wanted to let its initializer take an initial value. In asset.swift, remove the default value from the property and add it as the default value of an initializer argument. Okay, so what? Get rid of the empty closure. Okay. And then in the initializer, self change handler is equal to change handler. Oh, I didn't do it right. Okay. Initializer string value double change handler of type value change handler is equal to that same empty closure, but now it's part of an initializer, so we can just pass it. Okay. Hot dog. All right, so then close. What's the problem? Oh, they're probably going to tell me. Okay. Because the empty closure is the default value for the change handler argument of your initializer, current call sites that are not passing this new argument remain valid. But you now have a new error assigning non-escaping parameter change handler to an escaping closure. What do @ escaping and non-escaping mean? You tell me, brother. All right, so what is this here? Assigning, okay, that's, gotcha. I was wondering when we see those @ symbols, I see a lot of them in the standard library, just from perusing a bit. The empty. You have seen that the compiler helps look for possible strong reference cycles when you assign a closure to a property or when you assign a closure to a property of another object. When you assign a closure to a property of another object. Okay. You know that closure might exist for a while, and that objects that have been strongly captured by the closure cannot deallocate before the closure itself does. Setting a closure property always means that you must be on the lookout for possible reference cycles, but passing a closure as a function argument can be less risky. But passing a closure as a okay. If the function will execute the closure before the function returns. Never passing the closure anywhere else, then there is no possibility of a strong reference cycle. Okay, so it's executes before the function returns and isn't used elsewhere. Okay. The closure might still strongly capture its scope, but it does not matter because the closure will be destroyed when the function returns. Okay, right, yep. Also destroying any strong references captured. Okay. Tracking. A closure argument like this will not escape the function's own scope. A closure argument like this will not escape the function's own scope if a closure argument like this that will not escape the function's own scope is called non-escaping. Okay, very straightforward definition. You do not need to worry about closure captured strong reference cycles with non-escaping closure arguments. That's a nugget right there. All right. On the other hand, when a function accepts a closure argument that it might store in a property or pass to another function, the closure is called escaping. Swift wants developers to be aware of escaping closures arguments so they know to look out for strong reference cycles and consider using a capture list to change strong captures into weak ones. Swift enforces this warning by requiring that escaping closure arguments be marked with the @escaping attribute. Okay? An attribute, a keyword prefixed with the @ symbol, gives the compiler extra information about a variable or function declaration. In this case, escaping communicates that the closure can escape its scope, which affects which other warnings and errors you might get related to the closure. You will see more attributes later in this book. Now you know how to fix the error. Change handler, value change handler. Okay. At escaping That's not so bad. Okay. And we have to do that because it will, okay, so yeah, so it, that was one of their deals. Where did they say that? Yeah. On the other hand, when a function accepts a closure argument, that it might store in a property or pass to another function. So in our case, it is going to store it in a property. That one right there. Okay. And that's why we got to do that. Okay. So I mean, it seems like it makes sense. We'll see tomorrow. All right, escaping. ARC, which is automatic reference counting, is an amazing feature of Swift that protects you from lots of possible memory problems. Still, you should always be vigilant when working with reference types, and especially with closures, to ensure that you do not create memory leaks. Having said that, do not worry about memory leaks causing problems with your computer. When a program like cyclical asset stops running, all memory, including any leaked memory, is reclaimed by the OS. However, memory leaks are still serious, and even more so in iOS than in macOS. iOS tracks how much memory each app uses and will terminate apps that use too much. When an app leaks memory, that memory still counts as part of the app's total memory usage, even though it is no longer needed or useful. Yeah, I think we'll save this for tomorrow. This is, it's really interesting stuff, but yeah, it sends you all over. Lots of questions come up too. Yeah, so that's it for today, guys. We're going to wrap it up. Thanks for tuning in, and make sure you come back tomorrow. We'll be back tomorrow, same time as always, 11 a.m. Central Standard Time, and per usual, I'll also be back streaming 9 p.m. Central every day as well. If you want to come check out the 100 days of ranked Halo Infinite, I just hit Diamond last night, back at Diamond 1, so I'm 6 tiers from my goal. Got to get Onyx before the 100 days is up. It's probably going to happen, but we'll see. Otherwise, I'll see you guys tomorrow, 11 a.m.-ish. Take care of yourselves. Go eat something. Okay, bye.